for thousands of years. It was just a wandering red spark in the night sky. Tonight, we will travel across millions of miles and hundreds of years of history to walk along the quiet, dusty dunes of Mars. Before the heavy rockets, before the intricate glass lenses, and long before the robotic rovers left their tracks in the sand, there was only the quiet act of looking up. Imagine, for a moment, standing beneath a completely dark ancient sky. The air is cool and still. There are no city lights to wash away the delicate glow of the cosmos. Above you, a vast, silent ocean of stars stretches from horizon to horizon, a perfect dome of soft, white pinpricks. If you stood there long enough, watching night after night, you would notice something strange about one particular light. It was a deep, resting reddish-orange, a color like fading embers in a quiet campfire. And unlike the other stars, which moved together in perfect, predictable harmony, this little spark seemed to wander. It moved at its own slow, deliberate pace across the darkness. Sometimes it even appeared to stop entirely. It would drift backward for a few quiet weeks, tracing a small, invisible loop in the sky before slowly turning around and moving forward again. Today, we know this is simply an optical illusion, a beautiful trick of perspective created as the Earth passes Mars on its tighter, faster orbit around the Sunday. It is exactly like watching a slower ship drift backward as you sail past it on a calm, dark sea. But for centuries, that slow, wandering dance made the red planet a profound mystery. It was a celestial wanderer, charting its own course through the night. Then came a quiet, monumental shift in the year 1610. Galileo Galilei stood in the cool night air and pointed a simple tube of brass and ground glass toward the sky. It was the very first time human eyes looked at Mars through a telescope. Through his primitive lens, Mars was no longer just a spark of fire. It was a tiny, glowing disk, a tangible shape. The mental boundary had been crossed. Mars was a physical place. 50 years later, the picture grew just a little clearer. A Dutch astronomer named Christian Huygens spent his nights watching that same glowing disk through a much better lens. As he stared into the eyepiece, he saw soft, blurry shadows. He watched a large, dark patch slowly drift across the surface, night after night. By watching those gentle shadows move, he realized something beautiful. Mars was spinning. He carefully measured its rotation, tracking the shadows as they crossed the disk. He found that a day on Mars was almost exactly the same length as a day on Earth. A quiet, familiar, 24-hour rhythm of light and darkness. He also noticed a brilliant white glow at the very top of the planet. He had found the Martian ice caps. In the deep silence of the 17th century, humanity realized that this wandering red star was actually a world. A world with days and long nights, and winter ice reflecting the distant Sunday. And that realization was just the beginning of a very long, very hopeful dream. As the years passed, the glass lenses grew larger, and the telescopes reached deeper into the dark, and the dreams about Mars grew with them. In the late 19th century, the slow clockwork orbits of the solar system brought Earth and Mars very close together. It was a rare alignment, a moment when the two planets seemed to reach out to one another across the void. In a quiet observatory in Italy, an astronomer named Giovanni Schiaparelli spent countless nights staring through the glass, his eye adjusting to the faint, red light. He carefully sketched the soft, blurry shadows he saw. As he drew, he noticed faint, straight lines connecting the darker regions of the planet. In his native Italian, he called them canali. In his mind, he simply meant natural channels or deep grooves carved into the ancient landscape. But words travel across oceans, and sometimes their meanings change along the way. When his careful notes were translated into English, the word canali became canals. A channel is a gentle work of nature, a riverbed carved by time. But a canal is a deliberate work of engineering, and engineering meant intelligence. It meant life. That single, quiet misunderstanding sparked a beautiful, hopeful dream that swept across the world. Far away, an astronomer named Percival Lowell was captivated by this idea. He used his wealth to build his own observatory on a dark, silent mountain peak in Flagstaff, Arizona. For years, Lowell sat alone in the cold night air, staring through his massive telescope, drawing incredibly intricate maps of the red disk. He looked at the blurry shadows and imagined a dying, drying world. He imagined a brilliant, desperate civilization working together in the dust to build a global web of water, a system designed to bring melting ice from the poles down to their thirsty, waiting cities at the equator. It was a deeply comforting thought. A lonely humanity staring into the infinite dark, hoping to find neighbors just next door. But it was only a dream. The vast network of canals was not real. We now know they were just a gentle illusion created by the limits of early glass and the turbulent, dusty atmosphere of our own Earth. When the human eye looks at faint, blurry shapes in the dark, the mind naturally tries to connect the dots. We look for patterns. We look for familiar meaning in the chaos. The brilliant Martian engineers and their desperate fight for survival were nothing more than scattered, natural shadows woven together by human imagination. But that dream of a living Mars was so powerful and so deeply rooted in our hearts that it would take another 70 years before humanity finally built the machines to travel there and see the truth. For a very long time, the beautiful dream of a living Mars was enough to keep us looking up. But as the 20th century arrived, humanity learned how to leave the Earth. We began to build quiet, solitary machines. Machines made of polished metal and fragile glass, designed to travel across the deep, dark, freezing ocean of space. The journey was incredibly difficult. The distance between the Earth and the red planet is immense, a chasm so vast that the human mind struggles to hold it. It takes many months of absolute, silent drifting through the dark void just to reach the Martian orbit. In the winter of 1964, a small, delicate spacecraft named Mariner 4 began that long, solitary journey. It traveled for 7 months through the quiet cold, leaving the blue light of Earth far behind. It didn't have the heavy fuel to land, or even to slow down and enter orbit. It was designed to simply fly past, to drift through the neighborhood, coming just close enough to finally open its mechanical eyes and take a few precious photographs. When Mariner 4 finally brushed past the red planet, speeding through the thin upper atmosphere, it captured exactly 21 pictures. Back on Earth, in a quiet, tense control room, people waited. The digital images arrived incredibly slowly, transmitted line by tedious line across millions of miles of empty space. It took hours for a single image to form on the paper. And as the pictures finally resolved, the old romantic dreams of a bustling Martian civilization gently faded away. There were no oceans reflecting the Sunday. There were no dark forests. There were no cities, and there were no canals. Instead, humanity saw a quiet, resting ancient landscape. It was a world completely covered in soft, undisturbed dust and heavy, ancient craters. It looked eerily similar to the silent gray face of our own moon. The spacecraft's instruments measured the air, finding it incredibly thin, mostly carbon dioxide, and freezing cold. The surface pressure was a tiny fraction of what we feel on Earth. It was a sobering, heavy moment. Mars was not a struggling world fighting to survive. It was already asleep. It was simply an ancient, frozen desert, a place that had been perfectly, flawlessly still for billions of years. The realization meant that we were not going to find neighbors waiting for us. But instead of turning away in disappointment, we realized we had found something else entirely. We had found a pristine, untouched planetary wilderness, a vast, silent canvas, locked in time, just waiting for us to slowly, patiently uncover its deep geological secrets. When we finally returned to Mars a few years later, the planet seemed to be hiding from us. A new spacecraft, named Mariner 9, arrived to slip into orbit. But as it looked down, it found the entire world wrapped in a soft, impenetrable, global blanket of golden dust. A massive storm had enveloped the planet, turning Mars into a featureless, hazy sphere. There was nothing for the spacecraft to do but wait. For weeks, the machines silently circled the planet, watching and listening in the dark, waiting for the winds to die down and the dust to slowly settle back onto the dunes. And as the air finally began to clear, ancient giants began to emerge from the haze. The cameras revealed a sleeping volcano named Olympus Mons. It is so impossibly tall and so incredibly wide that its peak reaches far above the thickest parts of the Martian atmosphere. It stands as the largest volcano in the entire solar system, a monument of silent, frozen stone. As the dust cleared further, they revealed canyons so vast and deep that they look like enormous, jagged scars carved into the very face of the planet. A gorge so wide it would stretch across entire continents on Earth. Mars was not just a flat, cratered moon. It was a world of breathtaking, extreme, and quiet majesty. And soon, we decided it was time to finally touch it. In the warm summer of 1976, two small, highly complex landers named Viking gently descended through the pale, butterscotch-colored sky. They fired their retro rockets, blowing away the ancient dust, and firmly rested their metal feet in the rust-red soil. For the very first time in the history of our species, human eyes looked out across a Martian landscape from the ground. The panoramic photos showed a quiet expanse of scattered angular rocks, small drifts of fine sand, and a frozen horizon waiting under the cold air. The Viking landers reached out with mechanical arms. They gently scooped up the delicate red dust, pulling it inside their small laboratories, looking for any faint whisper of life, any sign of a microscopic breath hidden in the soil. They added nutrients and water to the dirt, waiting to see if anything would react. But the soil was ultimately still. It was full of ancient, highly reactive, complex chemistry. It bubbled and hissed with chemical energy. But it was quiet. There was no biological life hiding in the dust. Yet as those landers sat there, completely alone, watching the small, pale sun set over a distant, alien horizon, they proved something incredible. We could reach our hands across the dark void of space, and we could land safely on another world. After years of standing completely still, humanity decided it was time to finally walk across the quiet red dust. In 1997, a tiny, delicate explorer named Sojourner arrived on Mars. It was too small to use heavy rockets to land softly. Instead, it was wrapped in a large protective cushion of giant airbags. As it fell through the thin sky, it didn't slow to a hover. It bounced gently, over and over, rolling across the dunes, absorbing the impact before finally coming to a slow stop in a quiet valley. The airbags slowly deflated, pulling back like the petals of a metallic flower, and the tiny rover drove down onto the dirt. Sojourner was small, only the size of a microwave oven. It didn't travel very far, but it proved a beautiful, revolutionary idea. We didn't have to stay in one place. We could move. A few years later, in 2004, two larger, identical twin explorers named Spirit and Opportunity landed on opposite sides of the world. They rested on the surface, unfolded their solar wings under the pale sky, and opened their eyes. Their mission was simple but profound. Follow the quiet traces of ancient water. Opportunity rolled softly off its landing platform into a shallow, dusty crater. Almost immediately, it looked down into the exposed, layered stone at its feet. There, scattered across the dark ground, were thousands of tiny, perfectly round mineral spheres. Small, smooth, iron-rich beads that scientists fondly named blueberries. On Earth, these delicate stones only form when quiet. Liquid water rests on the land for a very long time, slowly shaping the minerals over millennia. It was the gentle, undeniable proof we had been searching for. millions of years ago, when the solar system was young, deep. Liquid water had rested on these peaceful plains. Mars was once a wet, flowing world. Spirit and opportunity were only expected to wander for 3 short months. Engineers worried that the heavy, constantly falling dust would eventually cover their solar wings, starving them of light and lulling them to a permanent sleep. But the Martian sky was surprisingly gentle. Every now and then, soft, invisible gusts of wind swept across the plains. These gentle dust devils would carefully brush the red dirt away from their solar panels, giving the rovers a fresh breath of light and power. Because of the kind wind, Spirit wandered through the hills for 6 calm years, and opportunity kept rolling, quietly and steadily, across the vast dunes for 15 years. It left a long, graceful, winding line of tracks in the red dust, exploring craters and ancient shorelines. It was a quiet testament to endurance, a beautiful reminder of how far a small, solitary machine can travel when the wind is kind. Eventually, humanity wanted to look even deeper into the Martian past. We wanted to know not just if there was water, but if that water could have supported life. To do this, we needed to send much larger, much heavier explorers. Machines the size of a small car, carrying heavy, delicate, highly sensitive instruments. Because they were so massive, they could no longer bounce on airbags. The impact would shatter them. They needed a far gentler touch. In 2012, a large, heavy-duty explorer named Curiosity arrived. It descended through the thin, freezing atmosphere, using a method that sounded almost like a science fiction dream. High above the ground, a special craft fired its engines, hovering quietly in the sky. Then it gently lowered the Curiosity rover on long, thin nylon cables. It looked like a spider, slowly descending on a delicate thread in the dark. As soon as the rover's wheels softly touched the red dust, the cables were instantly cut, and the hovering sky crane flew away to crash at a safe distance, leaving Curiosity in perfect, untouched silence. Curiosity landed in Gale Crater, an ancient, dry, and dusty basin. As it slowly drove over the rocks, drilling carefully into the stone over many years, it found exactly what it was looking for. It proved that this silent basin was once a massive, calm, freshwater lake. The chemistry in the rocks showed that this was a place where water rested for a very long time. A place that was once perfectly suited to hold life before the atmosphere thinned and the water dried away. 9 years later, a twin explorer named Perseverance arrived, descending from the sky, using the exact same gentle dance of cables. It traveled to a different location, a place called Jezero Crater. This crater clearly holds the curved, sweeping remains of an ancient river delta, long since turned to stone. Perseverance moves slowly, carefully collecting small, perfect cores of rock from the delta. It seals them inside quiet, ultra-clean titanium tubes and leaves them gently resting on the surface. They are small gifts, waiting in the dust for a future generation to come and bring them home. But Perseverance did not travel alone. Tucked safely beneath its belly was a tiny, delicate companion, a small, incredibly light helicopter named Ingenuity. In the thin, freezing air of Mars, where the atmosphere is less than 1% as thick as Earth's, flying is an extreme aerodynamic challenge. There is almost no air to push against. But one quiet afternoon, the little machine spun its long carbon fiber blades incredibly fast and gently lifted off the ground. It hovered, perfectly stable in the pale sky. It was the very first time humanity had ever flown an aircraft on another world. An extraterrestrial echo of the Wright brothers. It was only supposed to fly a few short times. But just like the resilient rovers before it, the little helicopter refused to stop. It survived the brutal Martian nights. It flew over the quiet dunes 72 times, becoming a faithful, buzzing scout in the sky, until its mission finally came to a peaceful end. We had learned to orbit the red planet, to touch the ground, to walk across the dust, and now to fly gracefully in the alien sky. Now the red planet rests. The rovers continue their slow, methodical journeys across the dunes. But much of the planet remains locked in deep, silent stillness. Millions of miles away, those small titanium tubes lie silently on the rust-red dust of Jezero Crater. They are waiting. In the coming years, humanity will attempt a quiet, incredibly complex journey to finally bring them home. A small, robotic ship will land near the tubes. It will collect the precious stones, and a tiny rocket will gently rise back into the dark sky, carrying the very first physical pieces of Mars across the vast ocean of space, back to the laboratories of Earth. But what about us? When will we finally walk alongside the rovers we have sent so far ahead? Sending machines made of metal and silicon is one thing. But a human journey is an entirely different kind of dream. The space between our worlds is vast, and it is filled with harsh, invisible radiation from the deep galaxy. The Martian dust itself is unforgiving. It is fine clinging and filled with harsh chemicals that we cannot breathe. To survive there, we will need to build entirely new ways to protect ourselves. We will need massive ships that can carry years of food and water, and heavy habitats that can keep the bitter cold and the toxic dust securely at bay. Because the challenges are so immense, the scientific community is not rushing. We know that this long journey will take time. It may be decades before we are truly, safely ready to leave the comfort of our blue world and step onto the red one. But there is no hurry. Mars has waited for billions of years. It has waited through meteor strikes, through the drying of its oceans, and through the slow freezing of its air. It will wait for us. From a wandering, misunderstood spark of light in an ancient sky to a complex, quiet world mapped by robotic wanderers, Mars has always captured our imagination. And one day, perhaps under a pale butterscotch sky, the quiet, geometric tracks of a robotic rover will finally be joined by the slow, deliberate, heavy footprint of a human being. Until then, the red planet continues its quiet, eternal dance in the dark, waiting patiently for the next chapter.